Pig is a top-level project with Apache. It is a top-level project with Apache. You can see that one. pig.apache.org. pig.apache.org. Like how you have hadoop.apache.org, you have something called pig.apache.org. They mention it very clearly here. The very beginning of this this document being clearly mentioned. Apache Pig is a platform. Apache Pig is a platform. What we mean by a platform we see later. For analyzing large data sets that consists of high-level language for expressing data analysis programs coupled with infrastructure for evaluating these programs. That is the reason why we are calling this as a platform. For what purpose this platform? For analyzing large data sets. And this platform consists of a high-level language that is called as Pig Latin. And Pig Latin is used for expressing data analysis programs. And that also is coupled with the infrastructure for evaluating these programs. So overall, if you see this closely, you understand Pig is basically a platform to analyze large data sets. This platform has got a high-level language that is called your Pig Latin. What is the purpose of this Pig Latin language? What is the purpose of this Pig Latin language? To express programs. The purpose of this Pig Latin language is to express the programs or to write the scripts. Hope you understand, friends, what I am sharing here. Plus, not only the language to express the programs, it also is included with the environment to run these programs. The environment to run these programs. So hope you understand, friends, what I am trying to share with you here. Pig is basically a platform to analyze large data sets. So when I am mentioning large data sets, I need not specially tell you. Large data sets, just nothing but your big data. Large data sets. So this platform has got a language and the environment to run the programs. Hope you understand the things that are being shared here. So if at all, if you want to master this pig, what you need to learn, I need not tell you now. Yes. Someone trying to answer, ask a question? Okay. Is a platform for analyzing large data sets that consists of high-level language for expressing data analysis programs, coupled with the infrastructure for evaluating these programs. I mean, running these programs. The salient feature, the salient property of pig programs is that their structure is amenable to substantial parallelization, which in turn enables them to handle very large data sets. Amenable to substantial parallelization. So this is where we need to apply our sense in understanding these technical documents. Substantial parallelization. I need not tell you what it means. What is that? Your massive parallel processing, what we have observed as part of your MapReduce, the same is being applied, or the same is the backbone for your pig event. So with this statement, we should actually elevate ourselves to that extent. Oh, when I write a pig program and run it through the environment here, probably those programs going to get converted into a MapReduce job and works as a MapReduce job. That level of imagination and understanding you should get. Then only you can learn things very fast. Because nowhere they are going to tell you this is like this. Because these documents are being written by the true technical experts. I don't think they will go to that extent like others who simplifies the technology or the language to the very best extent. You will not find these documents like that. But the interesting part to work with these documents is today something is been released, the very next moment you can get updated yourself. But if you depend on books, something of that sort, then you need to wait. Someone need to understand that, digest, then write and simplify it and write a book. Till then you need to wait. But it is not the case when you follow these technical documents. The moment it is been released, even if it is in the beta, you have the updation available. You can go through the document and upgrade yourself. Maybe initial days slightly tough for you to understand these documents as is. It takes time, but believe me, if you can follow the technical documentation, what I'm introducing now, it will be very easy for you. So please work with this one, friends. Then it makes more sense.
Hi, Srinivas. This is Prasad.
Yeah,
I just joined. Did I miss anything?
No, you didn't miss anything, Prasad. Yeah. So we just started. We discussed Pig is basically a platform to analyze large data sets. And this platform consists of a high-level language called Pig Latin, with which we write the programs or scripts. And we have the environment to run these programs. So in the background, your pig is going to make use of the substantial parallelism. That is nothing but massive parallelism, what we have studied as part of MapReduce. So this gives you the understanding that you write a pig script, and you try to run this pig script it actually gets converted to a MapReduce job. So there should be someone to convert your pig script into a MapReduce job. That is nothing but your compiler. There is a compiler here. Where that compiler is present as part of this environment only. With the help of this compiler, your pig script has been converted into a MapReduce job and then actually been submitted to the cluster. You know very well how your MapReduce job is going to make use of the massive parallel processing technique. We are clear with that. We are clear with that. Hope you are getting my point, friends, here. At the present time, pig infrastructure layer consists of a compiler that produces sequence of MapReduce programs for which large-scale parallel implementation already exists. Pig language layer currently consists of textual language called Pig Latin, which has the following key properties: ease of programming, optimization opportunities, and extensibility are the three key features of your Pig Latin language. So by the time, this is a benchmark, friends. By the time we finish Pig, we need to make sure every word of this, whatever I am blocking now, must be very clear to you. Every word. So we have some understanding now. We go through Pig and finally we need to get the understanding of every word that is written over here. That is what the barometer for us now. Whether we have understood Pig properly or not, in order to evaluate ourselves, that is what the benchmark. Hope you are getting the point, friends, here. Now look at this one, you understand. Have a look at this one, friends. Slash TMP slash sandbox slash Mary slash TMP slash sandbox slash Mary. For each in, this is what the line we have. In equals to load slash TMP slash sandbox slash Mary. So you look closely here. In equals to load in the single quotes /tmp /sandbox /Mary as whatever it is. This is what we call it to be, whatever we have written here completely, not just line. So whatever we have written, everything, this entire thing is what we call it to be. This entire thing is what we call it to be pig statement. And this is what we specifically call it to be relation. And this is the path to which from which the data needs to be read. I explain you this one a bit later. Load, you call it as a function, or you call it as a statement, you call it as, I mean, it is too early for us to comment on that, but you understand better. We are asking pig to load this data set, and that loaded data set is referenced using in. That is where we are calling it as a relation. That in is what we call it to be relation. Now I say here, pig hyphen f word count dot pig. Pig hyphen f word count dot pig. Pig hyphen f word count dot pig. That is what I said. We really don't know, but you just observe so that you understand. Whatever I mentioned till now, connecting to resource manager, map reduce layer, map reduce tasks. I don't know whether you are creating ZAR file, number of splits 1, total input paths to process 1. Where we came across all these things, friends? Where we came across all these things, friends?
My practice job.
Ah, now at least from this you need to understand. See, MapReduce launcher 0% complete. Total input paths to process 1. And you see here, before that, compiler, all you notice what is happening. You automatically, MR compiler, that is a MapReduce compiler. You see here, manage jobs. When you go to manage jobs, you are noticing here, it is still getting executed, 0% complete. What is application type, friends, here? What is application type? Are you following with me, friends? What is application type here?
MapReduce.
But what we actually submitted?
Big job.
Word count.pig is what we submitted. Word count.pig is what we submitted. Like how when we have submitted your MapReduce job in the form of a jar file, we got a ID and we got a name, we got an application type, everything how we got. No problem. Let us see what is. That's fine. See here what is output. You notice, dear friends, what is output? You notice, dear friends, what is output? So looking at this one now, tell me the statement that we have given, that we read here. At the present time, peak infrastructure layer consists of a compiler that produces sequence of MapReduce programs for which large-scale parallel implementations already exist. What is that? Your MapReduce. Textual language called Pig Latin, which is very easy for you to understand, which we have observed. And you see, going to this U browser also, see here, it worked as a MapReduce job in the background. I think there is a problem with history server. One second. I think you have understood why we are not getting the logs and all that stuff. Job history server is down. So with this you understand who is going to maintain or track the details of. Here you got the job been executed. When you click on this one, could not find job application of this because of the reason The job history server health is concerning, and moreover it is down. The job history server is down. Let us make that. So anyhow, that is not the concern for us now at this stage. So we have seen very clearly what a pig is. Now tell me friends, after giving this much introduction to you for the last 15-20 minutes, what is your conclusion? I've explained you what is pig, and I've explained you in detail what is pig and what we can do with this. And I've shown you even how you run your pig script, when being executed, what is happening. All these things you have noticed. Now tell me, what is your conclusion? I understand it is too early for me to ask this one, but I want to get the feel from your end. What is your observation? You notice that we are getting the outcome now, why the job history server is needed as part. So it is exactly working like your MapReduce job only. No much difference. If you might have gone through, its type is MapReduce, name is piglatin wordcount.pig, which we are seeing very clearly here. When you go into the deeper sections of this job, you see you have a map task and you have a reduce task. You have a map task and you have a reduce task. Hope this is pretty clear to you friends, what I am sharing.
Srinivas, can you show us how to run the pig script again one more time?
That's it. Pig-f, pig-f, and wordcount.pig, whatever the script. Of course, we don't do this one in the beginning when you're learning your pig Latin language. We use a gun shell, which is the interactive way of working with your pig. We write each statement and see if there is any problem in that statement. We come to know, we rectify that. So we go in an interactive mode so that your learning process is going to be much interesting rather than you writing the pig scripts and all. But this is to give you the big picture of what pig is and what we can achieve with pig. That is the reason why I did this one as part of this one discussion. So what is your conclusion, friends, with this? What is your conclusion?
Yeah, pig script is nothing but it's a MapReduce job in the background. Instead of writing 200 lines of Java code, it's a very easy way to write like 4 lines of code, MapReduce job, based on understanding the data set description of the requirement.
Oh, that's very interesting to hear. That's very interesting to hear. Prasad, yeah, very interesting
Yep.
to hear, Prasad. So can I say like this, Prasad, like, pig is basically higher level of abstraction, higher level of abstraction on the top of MapReduce. Can I use this statement? Higher level of abstraction on the top of MapReduce. Can I use that statement?
Yeah.
This is what usually the interviewers are going to expect from you. Because this kind of statement you will not find anywhere in the document or being shared by anyone as part of any discussion or blog, whatever you take. This kind of conclusion you need to get on your own. Higher level of abstraction. Why I left the space in between intentionally is to make you to understand higher level of abstraction. What level of abstraction? Scripting level of abstraction. I can say scripting level of abstraction on the top of MapReduce. You may ask me one thing, why Srinivas, you are specifically mentioning scripting level of abstraction on the top of MapReduce? Because of the reason, now very immediate to this, we will be working with, very immediate to this one, we will be working with one more that is called your Hive. When we come to Hive, again I come to the same, I say SQL level of abstraction on the top of MapReduce. SQL level of abstraction on the top of MapReduce. I hope you are following what I am trying to share with you here. Even when we come to Scoop, when we come to Uzi, anywhere across your ecosystem, we always link up that with your MapReduce. That is the reason why I took so much pain for to explain you the aspects, and I am asking you, insisting you to go through MapReduce thoroughly. I'm not expecting you to write tons and tons of MapReduce programs on your own, but I'm expecting you to understand the full-fledged life cycle of a MapReduce job based on your input format, how it is going to read the data from your HDFS, because input path is on HDFS. Input path, from the input path we are going to read the data from HDFS in the form of splits, not in the form of a block. What is the difference between a split and a block? We need to be clear. Each split is processed by one mapper with the help of record reader. Record reader is going to read the records and give it to the map function in the form of key value pair. And key value pair and record are decided based on the input format only. If it is a text file, what should be the record and what should be the key and what should be the value are being decided. And all your outputs of the mappers functioning on the same node are aggregated locally with the help of combiner. And after the key value pairs are being combined with the local aggregator called combiner, we need to decide which key value pair should go to which reducer. That is marked by the partitioner. Partitioner is going to just mark that this key value pair should go to this reducer. Who actually transports that one? Your shuffle actually transports that. Shuffle phase of your MapReduce job actually performs the transportation of the key value pairs to the respective reducers. And then you have the sort phase. Before the key value pairs are given to the reducer, all the key value pairs are being sorted before they are being given to the reducer, and finally being given to the reducer. Reducer is going to perform its action and its output is being written to HDFS. its output is being written to HDFS. Anything that happens in between is all being stored on the local file system. On the local file system. That part, if you are able to understand, learning pig is just a matter of 3-4 hours. I don't claim that you become expert in pig in 3-4 hours, but covering entire pig in 3-4 hours should not be a problem, provided you go through that one. That is the reason why I think this diagram is more apt, friends, now. This diagram makes sense? This diagram makes more sense. So I've explained you all what is pig and all, and running pig. You can run pig in different forms. You can run your pig script using your pig-f and you give the script, you are able to run that and see the expected outcome. Usually will not dump the output on the console except during your experimentation or during your development phase. In the production, we never dump the data onto the console. Once your experimentation is done and you confirm that your script is running as expected, then you're going to comment all the dump statements and you make your data to be preserved as part of your HDFS. That's the reason why we have something called, I think you noticed here, there is something called store. And that is actually the place where your output is being stored. This is equivalent to your output path, nothing more than that. And this is equivalent to your input path. And this is what the job is. So your MapReduce direct implementation is being abstracted in the form of statements as part of your pig script. And that's what the beauty part here, friends. Hope you understand. Let us go into the deeper details. You say pig and you press enter. Pig and you press enter. It takes you to a shell, that is what we technically call it to be a grunt shell, where you can write the statements and work with them interactively. That is what we call it to be the interactive mode of your pig. Here I can write all my pig statements. And this is how I'm going to do it now. What the data sets I have. Based on the data sets, look at this data set, friends. Student data.txt. Student data.txt. Class. Each is a record here. Each line is a record here. And line is into 8 tokens separated with comma. Class, name, and 6 marks. Class, name, and 6 marks. And you see here, ES data equals to load. Let me put the data set into my HDFS. Hadoop fs -copy from local student data.txt /tmp/ /tmp/sandbox. That is a place to which I am copying my data set. /tmp/sandbox /student data.txt using average Have a look at this one, friends. We don't know what has happened, but again we got the grunt shell. Again we got the grunt shell. And you see here, relations can be explained. Relations can be explained. You see that here. Explain is data. You also can use describe as data. Schema for S data is unknown. Schema for S data is unknown. That is the reason why we need to go with as standard, that is a char array type, name, that is also a char array type, lang1 is int type, lang2 is int type, lang3 is also int type, then maths int type, science int type, and social int type. Now the same describe I use, friends. It is saying S data relation has got the schema of this one. Now I need not explain you why we need to learn about data types. The first and the foremost step in learning any language is to identify the data types, friends. The first and the foremost. You may ask me one thing, what is the advantage of attaching the schema to your data set? The advantage is, I can say now, required data equals to, for each S data, generate std comma name comma max, and I say here dump our data. Then from this huge or big data set, of course we have a very small 33 record data set here, but reality, pig is basically meant for processing large data sets. So keeping that thing in the mind, then if you give this kind of thing to your pig, what it do is, it is going to just extract the name, standard name and the match marks, ignoring the other stuff. I think you are seeing here, friends, very clearly what is happening. During your learning process, you are going to experiment, doing all this stuff. You create your relations and you use your relations. What is that we did? What is that we did? What is that we did? We loaded the data set, that is S data equals to load /tmp/ sandbox /Mary or student data.txt using pig storage, P is capital and S is capital, where tokens are separated with comma, as I say here, what is that? std char array, that is nothing but the string equivalent. Name is also a char array. And what is the next thing? lang1, int lang2, int lang3, int maths, int and science, int and social, int. And our data equals to, that is called required data, equals to for For each in SData, I am asking to generate only STD, name and match. And I'm saying dump our data. If you look at these three, why we are doing like this, the interactive mode is to make ourselves comfortable, get the familiarity. Now see here friends, I only got the standard, name and match. So if I want to perform this kind of operations, not only this one, I can also say one more thing, filter data equals to filter S data by match greater than 85. Then what is going to happen friends? Dump F data. Dump F data. I will only get, look at this one, I will only get filter S data by match greater than 85. Then what is going to happen? That is where we need to understand here friends, what is this S data? S data is nothing but a relation, and how efficiently and effectively we are using these relations as part of the subsequent statements, that we need to have a clarity. That we need to have a clarity. So if you look at this execution, you will be getting, now what is that we did in between? Maybe you want, you can do this one, or you can also write one statement, that is filter data equals to filter S data by match greater than, suppose if this relation is not associated with any schema, writing these kind of statements never possible. That is the reason why we need to attach the schema to your relation. While attaching the schema to your relation, you need to assign a data type to each token or each field. And that is the reason why while learning your Pig Latin language, you must learn not only for this purpose. Without learning data types in any language, we will not be able to do anything in that language. So the first and the foremost step in learning any programming language is to learn the data types you have there. Go back here and see what is the output you got. You see the fourth one, 98, 87, 87, 87, 87, 88, 88, 89, 89, 88, 88, 88, all greater than 80 only. I hope you understand, and more than 85, what you mentioned. That is the reason why you got only. Suppose if I make this as greater than 90 and I say here dump F data, you should get only one record. You should only get one record. So you understand from this how this pig is functioning for you in the background. And immediately the moment you say dump F data, you need to get the visualization, what kind of MapReduce job might be running in the background. That visualization, if you are able to get friends, you are done with your entire Hadoop. You are done with your entire Hadoop. Believe me, the moment you write some pig statement and now you imagine what could be its equivalent MapReduce in the background, that visualization if you are able to get, you are done. You can work with any component in the entire ecosystem. You need to get that visualization. Can any of you tell me, friends, what MapReduce job is going to work in the background? What is its our structure and all? Can you tell me those things, friends?
I guess that is going to be whatever you declare as a variable. So it's doing that process behind it.
Come out again? No. What MapReduce job? I mean, can you imagine the code that is going to be inside the MapReduce job that is going to run in the background for you?
Can you say that again?
Yeah.
Could you please repeat that one?
No, when I am running this one, I got the output here. I think you noticed here the output, only one record I
Yeah.
got because of this one. So you see, your statements, whatever the statements you're writing, those statements will not be executed. They only will be syntactically, whether they are correct or not, that only going to be verified when you give each statement. When you give each statement. Okay. When you give each statement.
Mm-hmm.
I think you're getting my point. When you give each statement.
Yeah.
When you call dump, then only the execution is happening in the beneath layers.
Right.
Call dump, then only the execution is happening. Now, when the execution is happening, if you go and see, I don't know, you go and see here in the manage jobs section, how many jobs been executed now. See here the jobs that have been executed. All these are the jobs been executed. Okay. If you go and see this last job that been executed, and in the tasks section, let it this come. Tell me what kind of task will be executed for this one?
That is map reduce.
Reducer.
Oh, no, no. Only map task will be executed. There will not be any reduce task because there is no aggregation involved here. I am just, if you look at this statement, what I'm doing, I'm just filtering the data. That can be done in the map part itself, right? Why we need to have reduce? Why we need to have reduce?
Because that is the top of that reduce, that big one.
No. You're mistaken. I told you very clearly, when you write a pig script and you run this one, it converts as a map reduce job, I said. But it is not mandatory that in every conversion there should be a reduce phase. The job is a map reduce job. We call it as a map reduce job, but it is not mandatory that every job must have a reduce phase also. Only map phase is sufficient here because we are just doing the filtering. That filtering can be done in the map itself. When your reduce will come into picture only when you are performing some aggregation. When you are performing some aggregation, then only your reduce will come into picture. Then only your reduce will come into picture. When reduce will come into picture, I am going to show you now. G data equals to group S data by STD. G data equals to group S data by STD. Now I say describe G data. See here, group name. Inside each group again we have bunch of records. That is where we call this as a inner bag. This is called as inner bag. Inner bag. Your relation itself is considered to be a bag, and as part of the relation also we have one more bag that is called inner bag. And you may ask me one thing, hey Srinivas, how we come to know all these things? You can see here in the getting started part, you see how you start with your requirements, big Latin statements, big picture or overview you get. Loading, building and all these things we need not worry because that is already been made available as part of your cloud environment. We need not do that. So how we start your pig in the local mode, in the map-read mode, in the batch mode, running your short-lived jobs, running your long-lived jobs, so pig Latin statements. This is going to give you the big picture, whatever I'm showing you here. But in order to go to the precise level, that is, you go to your pig Latin basics. There, it is going to give you the details. What are the reserved keywords? and the syntactical aspects of your, what are the data types you have, what is the case sensitive behavior of your pig, and as part of the data types, please read this one very closely, friends. Whatever I am blocking here, please read this one, then you will be able to understand what I am trying to share with you here. So for that sake only I am increasing its size intentionally. So please go through this part, only this part, for a minute, then you understand, and you also read this one, then you understand what I am trying to share with you as part of this discussion. Please. So what we mean by a relation, we understand here. A relation is a bag. A bag is a collection of tuples. A tuple is an ordered set of fields. A field is a piece of data. So now I think you understand here, friends, what I mean by a relation. This A is called the relation, and this is actually referring a collection of tuples that is nothing but a bag. As part of that bag, if you have one more bag, that is what we call it to be inner bag. What we have observed now, here if you see closely, this is called, see, G data itself is going to refer, this itself is a bag. G data equals to group S data by STD. G data equals to group S data by STD. So we are specifying that one here, and we see. Now I say dump G data. Now this time I am saying dump G data. Have a look at this one, friends. Then you will be able, that is what I am saying every time. Your strength or the knowledge on MapReduce should be useful to you everywhere. The moment some pig script is running, you should immediately get the visualization. Oh, for this pig script, either one MapReduce job is going to be generated in the background, or a sequence of MapReduce jobs going to be generated. If one MapReduce job, whether map and reduce phases both will be there, or only map phase will be there. See, if reduce phase is not there, there will not be combiner, partitioner, shuffle sort and reduce. Only when reduce phase is there, these will be there. Otherwise, only map phase will be there. So that you need to understand, friends. If you think all these things logically, you yourself will get the understanding. Only when reduce phase is there, you'll be having all these. What all these will be there? Your combiner, your partitioner, shuffle, sort, all these will be there only when you have the reduced phase. So you need to first define or decide. You need to first define or decide whether your MapReduce job. Look at this one here. You write a pig statement or you write a pig relation. For that relation, you need to get the understanding. So this pig statement or a script, what it actually generates. It generates a MapReduce job or jobs. If it is a MapReduce job, then immediately, when only one MapReduce job, whether only mapper phase or mapper phase and reduce phase. If only mapper phase, what logic could be inside the map function? To that level, we should be able to visualize. Then only you can be a good Hadoop developer. If not, if we are not getting that visualization, then we are lagging somewhere. We should immediately make our skill set strengthen in the MapReduce. Then only it will be. Now see here, for class 1, these are the students. For class 2, these are the students. For class 3, these are the students. For class 4, these are the students. For class 10, these are the students. I hope you are getting the point, friends, what I am trying to share with you here.
Yeah.
Now, my intention is not to show you this one. My intention is to show you when you go to this now, this fifth job, we need to decide going to the task. Why we got both map and reduce?
Because you use that group.
So every pig statement or a pig relation that you write, you should have an immediate evaluation or visualization in the background. So in the previous jobs that been executed in the background, go to the third one even. There you go and see. If you look into the task, only map task will be there, but there will be no reduce task. I think this makes more sense, friends, for you to understand. So what is the next thing that needs to be understood by us? What are the data types we have? What data types we have? We have these data types.
Srinivas, can you hear me?
Yeah, please. Hello?
Hello. Yeah, can you hear me?
Yeah, I'm able to hear you. You can, please.
Yeah, I have a question. So as you said, like, can you explain us a little bit more about, like, in what cases is the mapper only triggered, and in what cases, like, the script is going to trigger mapper and the reducer?
Now that we need to get the visualization. There is no thumb rule here that in this case it must be, in this case it should not be. What statements you are using. Now if you see the script, the statements that we have written here, for each S data generate standard name and match marks. Now tell me, for this sake, mapper and reduce tasks are required or only mapper task is sufficient? See, there is no document written anywhere that for these pig statements only mapper task will be there For these, reduce will be there. There is no document written like that. With the statements that we are writing, we need to estimate. Oh, here we are only extracting a part of the record. Now tell me, for that sake, any aggregation is required? Because reduce comes into picture only when aggregation is needed. If aggregation is not needed, reduce will not come into picture. Now keeping that in the mind, are we doing any aggregation with, for each S data generate this one? Are we doing any aggregation?
No.
So obviously no reduce will be there. No reducer phase will be there. Now filter S data by match greater than 90. Are we performing any aggregation? No. That is the reason why there is no reduce phase. But when I use a statement called, what is the statement I used? G data equals to group S data by STD. I want to group the data based on standard. Now aggregation is there here. That is the reason why we have got reduce phase also as part of this task, and we have seen even the reduce, and we have seen the output also very clearly. The output is for class 1, these are the students. Now this whole thing is called bag. As part of that, this is bag again. That is the reason why we call this as inner bag. Inner bag. So these terms, initially when we listen, maybe it sounds a bit odd, but when you start going through the documentation, this is the best way to update your skill set on any component. Of course, when you read the document on your own, maybe it takes more time for you to get the understanding of this one. That is the reason why I work as a catalyst. Most of the stuff I am giving it to you, explaining you and showing you practically. Because as I promised in the beginning of the course, we don't run by PPT. Our sessions are not PPT driven sessions. They're all purely practical. That is the reason why every concept we are seeing it practically to make ourselves sure, yes, this is what is going to happen in the beneath layers. When I am able to run that in the session, definitely when you go back to your practice, you should also be able to run that one and get the expected outcome. So as this is a Pig Latin language, this also will have data types. What data types we have here? Int long float double in the numeric section, char array, byte array, char array for the sake of character data, byte array for the sake of binary data. Char array is nothing but your string kind of thing. Byte array is for any other than your character data and the numeric data. You want to preserve some binary data, you'll be using byte array. We have Boolean, date type, big integer and big decimal. Simple. These are considered to be my simple data types, because data types in Pig Latin, in the Pig language, are broadly classified into two: simple and complex. These are simple, and complex are tuple, bag, and map. Tuple, bag, and map are considered to be the complex data types. Now, using these data types, what can be done? You can, instead of you loading the data in a generic form, you can load the data in a specialized form, so that the loaded data can be further synthesized or processed. That loaded data can be further synthesized or processed. Hope you are getting my point, friends. So once you are done with your data types, how you work with your nulls? In Pig Latin, nulls are implemented using SQL definition of null as unknown or non-existent. Nulls can occur naturally in data or can be the result of an operation. Can be the result of an operation. What is that? Null as unknown or non-existent. Unknown or non-existent. I hope you are getting the understanding what I am sharing with you here.
Srinivas, we lost you in between. Is it only me or Ram? You guys are okay? I think.
We're okay, Prasad.
Yeah.
Probably.
I think Ram, something might went wrong with you, Ram.
No,
That's
it was fine.
Prasad.
Yeah, okay. So am I audible to you all the time or no?
Yeah.
Yeah.
Okay.
I lost something. Just 2 minutes. Can you
Okay.
start this after the data types?
Okay. So you look at the data types aspect, all the data types been mentioned there very clearly. I advise you to go through, but to make it simple, data types in pig are broadly classified into two. One, simple data types, and the other one, complex. Under simple, you have noticed int long float double, byte array, char array, then we have boolean, then we have big integer, big decimal, big integer and big decimal. We have date time, and coming to the complex, we have bag, then we have a map, and then we have a tuple. I think you see that here. Tuple, bag, and map. You see here, int long float double, char array, byte array, boolean, date time, big integer and big decimal, and here you have tuple, bag, and map. These are the data types. And coming to the nulls aspect, what is a bag or what is a map? It's a syntax also you need to understand properly, friends, here. Your tuple is in the normal braces, your bag in the curly braces, and your map in the square braces. That is what the syntax to represent your respective complex data types. And you also see here nulls, how nulls are being treated. You can get the understanding of that and how things, expressions. In Pig Latin, expressions are language constructs used with the filter for each group and split operators as well as eval functions. Expressions are written in conventional mathematical infix notation and are updated to UTF-8 character set. Depending on the context, expressions can include any pig data type, any pig operator, any pig built-in function, any user-defined function written in Java. So in Pig Latin, you see, we have now, what are the expressions that are possible? You can see those here. You have expressions that are related to Boolean, tuple, general, and schema related that we have already seen. And this is the important thing that we need to understand. How Pig is going to handle the schema and why schema is so much important. Please have a look at this one. It's all theoretical stuff, no practical. What all practical is needed, I am showing you practically to make you to understand, even taking the input and showing the output so that you will gain the confidence. Yes, this is what the purpose. Now, the same I ask you here. Suppose if I don't create the relation like this, you think the other statements that I used is possible? Please be active in the session, friends, so that it will be more interactive. If I don't create this relation like this, attaching the schema, you think it is possible to filter the data based on what you need, group the data based on what you need, and extract the data what you need? It's definitely not possible, right? So you understand why we need to attach schema to your relation. What is the impact of not attaching the schema to the relation? That also you need to understand. I did this one. Now I say describe yes data. You are getting the very clearly this one. So I can easily and I can comfortably say, what is that I can comfortably say? Filter this yes data by max greater than 90. And I also can say, what is that? For each yes data, generate standard name and maps. I hope you are following with me what I am sharing with you here.
Yeah, clear.
So I advise you to go through the arithmetic operators that we have here. What arithmetic operators we have, and see here what arithmetic operators we have. The same for each S data, generate standard comma name comma maths plus science plus social by 3. Dump R data. Now tell me, friends, whether both map reduce phases will be there, only one map phase will be there in the background.
Only map.
Reduce also there. Map and reduce.
Reduce will not be there. Why reduce will be there? I am just calculating the math, science, social by 3, right? No aggregation is there here. There is no aggregation at all here. There is no aggregation at all here. Why there is no aggregation? There is no aggregation for the reason we are not performing any activity that needs to be summarized from all the mapper phases. Whatever the output that we get from the mappers, that itself is the final output we are expecting. That is why there is no reduced phase here. What is that we are doing? For each record, I am just extracting the standard name and the average of 3 marks. Why a reduced phase will come into picture? A reduced phase will not come into picture at all. So I was able to use even arithmetic operator as part of my relation, as part of my pick statement. So you need to understand how we can make use of your operators. You can see that here, different operators, what addition, subtraction, multiplication, modulo, and your ternary operator that is called binary condition, case, and that is where it been example been given here. It is something like this. Also can be used as part of your pick statements. So you need to understand when we are using these arithmetic operators between bag and a bag and a tuple, bag and a map, bag and all these things, what it is going to result, it is telling you with this table. So I don't think you need to go through this table to understand that. We ourselves can think logically and understand when the operation between two different data types happens, what could be the result? We can easily estimate. When the same plus operator happens between two bags, an error happens because your arithmetic operators cannot be that easily applied. Say for example, you apply this long and int long and int, or long and long, you say here, the result is a long. Int and int, I think you see here. So long and int, what is that you are getting? So you can see that one here as part of your table to understand how each operator is performing and giving. You also can apply your Boolean operators like or, not, and kind of thing to perform various things. Filter A by, I can write the statements according to my context. I think now you're able to see, friends, here. All 33 records we got, but how we got the 33 records? The average of 3 marks, math, science, and social. If you go and see your Hue browser, in terms of the task that is being executed now, you go to the last one, and there you see, you'll be finding only mapper task. You'll not be having any reduced task. You'll not be finding any reduced task here. You'll not be having that. So hope you understand what I'm trying to share with you here. The same statement I also can perform in such a way. Filter, see the statements we have. Filter yes data by maths greater than 90 or science greater than 75, or I can use this one to make things happen, or social greater than 65. Hope you understand what is that. Oh, there is a typo here. See here, if there is any mistake, immediately we get the error. That is why we are interested to use the grunt shell, so that it is going to be very interactive. So you can make use of your Boolean operator, something like this: maths greater than 90 or science greater than 75 or social greater than 65. Matching with this condition, what data you get, that. Now if we say here describe, it is a good practice all the times, friends. So how F data schema is going to be? F data schema is going to be like this. F data schema is going to be like this. Hope you are getting the point. And your casting operations, how it is going to happen, that also been mentioned clearly here. So I advise you to go through this one, and even the comparison operators, less than, equivalent to, greater than, equivalent to, double equivalent to, not equivalent to. You may ask me one thing, Srinivas, why we need to learn all these things? Is for the reason Pig has got two aspects, what we discussed in the beginning. It has got a language and it has got the environment. That is why we call it this as a platform. It has got two parts. One, the language with which you are going to write the scripts. Using this language, if you need to write the scripts, you need to learn the language semantics, the language features. What data types it supports, what operators it supports, what statements it supports, and what features, built-in features it allows you to use. Built-in features, there are built-in functions that are already been developed as part of the language, which you can directly use. If those are not sufficient to you, then you start developing your own called user-defined functions. So that is the reason why we are compelled to learn the language called Pig Latin. Because we need to know whether the feature is already available or not. If not available, how we can customize. I think you remember the statement, friends, in the beginning. The beauty of Pig is ease of programming. Wherever required, performance can be tuned, and wherever required, you can customize. The three features what Pig is going to provide you: ease of programming, optimization techniques are there, and the ease of customizing this. Customizing, at times when it is required to to make this to work as per your requirement, you can enhance this one or enrich this one by writing your own custom functions or user-defined function. That's what we mean by that. So this is all about your very basics of pig language and how things can be executed. And when you're writing your pig statement and you run it, how that is going to be in the background. Whether it is going to convert that into a MapReduce job, what kind of MapReduce job, series of MapReduce jobs, or a single MapReduce job. And when it comes to the MapReduce job, whether map and reduce both or only the map phase. So that visualization we should get. So that comes only with your practice, friends. So please start working with this one. Don't neglect. So thinking that Srinivas has already executed everything in the session, if I just go through the recording, I can easily understand. You can understand. But you need to gain the confidence that you also can execute the same thing. So please go through this one. We are going to see how we work with complex data types. Say we have something called have a look at this data set, friends. This is one record. Closely observe. This is one record where name of the player, this is a baseball data set, name of the player, to which club he belongs or the team he belongs, and what roles he perform as part of the team. Roles I mean left fielder, outfielder, then we have a hitter, designated hitter, a pitcher, all these comes under the roles he plays as part of the game. And this is what we call it to be the profile. Profile I mean how many games he played, what is the average batting, what is the highest score, and all those details. How many grand slams he played. So all those details put together profile. So this entire thing is what we call it to be a baseball data set. If this data set is given to you for processing, how you do that one? I want the inputs from your end, friends. If this is a data set given, how you are going to process this data set?
So as per the data, I can understand that is a bag also there.
Oh, very good. So not just simple data types, we have even complex data types here, like that is why I asked you, this is nothing but a bag kind of thing. Inside the bag we have a tuple, and this is like your map where we have a key value pairs in the square brackets. So you see that one here, this is a key value pair. Whatever you are seeing here is a key value pair. This is a key value pair. I hope you are getting the point what I am sharing with you here. Now if this kind of data set needs to be worked out, baseball.pig, if you see, have a very close look at this one, friends. What is that we are doing? Using pig storage as name is a char array, team is a char array, position is a bag. Inside that bag we have a tuple. Inside the tuple we have a field. That field is a char array type. See, superficially it may be a bag, but inside the bag what we have? We have tuples. Inside the tuple what we have? Fields. So here we have only one field. That is the reason why we mentioned like that. Are you able to understand my point, friends?
Yeah.
So I can comfortably Hadoop fs hyphen copy from local. I say here, what is that? Data sets, and then baseball.txt slash tmp slash sandbox. I copy that baseball.txt into my sandbox, and here, what is that we do? Is that over? Yes, it's copied successfully. Now here, baseball equals to load slash tmp slash sandbox slash baseball.txt using pig storage as, what is that? Name, which is a char array, and the other one is a team or a club, whatever. Team char array. What is the next thing? Position. What is its type?
Bag.
Yes, its type is bag. And inside that what we have? Inside that what we have? Tuple.
Tuple.
And inside that what we have?
This is a map.
Map.
No. Inside that we have a field.
Yeah, char array field.
Right. So you look closely there. Yes. And then we have a profile which is a map type. Now I say here, describe baseball. What did he say? Name a char array, team a char array, position as a bag, that is where the curly braces. Inside that we have a tuple. Inside the tuple we have a see, inside tuple we actually need to have fields. But in this case we have only one field. That is the reason why we mention only p char array. And profile is a map type. I hope you are following with me what I am sharing here. Now, our data equals to, for each baseball, generate name comma team comma, what is that we do? What is that we do?
Position.
Position. Can we specify something like this? Position of 0? Is possible?
No, it's a char array.
No. I want to access only the first one. Say, let him play multiple roles, but I want to get only one role. I want to get only one role. That is what I am saying here.
Okay, got you.
Can I do that? I think you noticed here. Syntax error, unexpected symbol at or near position. Then how your bag elements can be accessed. How your bag elements can be accessed. You're getting the point what I'm sharing here. Are you able to understand, friends, what I'm sharing here?
Yeah.
Yep.
So how you are going to access that then?
So you can use in a curly braces there.
So you mean to say here like this? This one?
Yeah.
Let us use this one and see. What is that?
You have, yeah,
Dump our data. Let us have a look at that. So one thing we need to understand here, when we have a data set something like this, what is been shown, when we have a data set something like this, how it can be loaded, when your basic types or your simple types not sufficient for you to work with your, then we can make use of your complex types. So in order to load this kind of data, we are using, what is that we are using? Bag. And in order to load this kind of data, we are using map. And you may ask me one thing, Srinivas, how we are going to get the data sets like that? I am not expecting data sets to come like that. If data sets are like that, we are going to use it. If data set is in a different form and not in any of the expected form, then we have a provision called developing a custom loader. You can also develop a custom loader. So using your pig storage, the name is going to sound odd to you here, storage, pig storage, but that is called a loader function. Of course, it is also a storage function also. That is the reason why we have given the name called pig storage, but that is actually loading the data. That is why you are using load so and so data set using pig storage. It is going to work as both loader and storage. So if your data set is very typical, if you are not able to make use of the pig Latin built-in features, then you can develop your custom. You can develop your custom pig loader, and using that loader you are able to load the data. Now I think you are able to see here, friends. What is the output you got? See what is the output you got? Not every time we are getting this one. You notice that one? Not every time you are getting the runs. Runs you are not, say in this case you don't have runs at all. Name of the player, to which club he belongs, and the positions, and we are asking to give the runs. From the profile, we are not asking to get everything. What we are asking? We are only asking to get, runs from the
runs.
profile. If runs available, you are going to get. If runs not available, then you will not be getting. You will be getting empty saying that for this particular player, no runs. I think you got the understanding how you work with this. Make sense, friends?
Yep.
So now, if it is a case of your, one second. From the bag, we should be able to get One second, there is a syntax for that. Uh, One second. Map schemas, bag schemas, yes. Tuple bag. In the bag, we should get mm, so position. If I want to get only one position, position dot one second. Describe baseball position as part of the position. Could not resolve position dot p. I think we already used this one. Could not resolve. For map, we are able to get that. For position, we want to get only one
So you
thing.
can use a square bracket. Instead
Pardon?
of parentheses, you can use a square bracket.
Inside the square brackets, you need to use that bracket again. It's similar to the syntax.
No, that also if you are using, it is not recognizing.
No. Inside that, another normal brackets, normal brackets.
So you mean to say another this one?
Yeah. Yes.
I don't think.
That's the syntax. Okay.
I don't think because it is definitely with the dot only, no second thought. Need to make, I mean, because that is all the language defined. We don't have any, again, when we go to Hive, Hive has got its own syntax again. And Uzi has got its own syntax, all the syntactical aspects. So let me just get that. Whatever. So it should be with the dot only for sure. Bag is a collection of tuples. In this case, the schema defines a bag. So we are defining a bag. But how we access the first no issue for that. Ah, okay. So we will not be able to access that one directly. No, not possible. So we need to flatten that position because bag being a non-linear data structure, it is a non-linear, right? It is not a linear data structure like your other things. Map, if you take, it is a linear where you have a key value pairs, bunch of key value pairs. But if you take this position, I mean this bag, inside bag we have tuples. Inside tuples we have there could be n number of tuples inside the bag, and inside each tuple we can have n number of fields. So this being a non-linear structure, directly accessing with the position may not be possible. That is the reason why we have an operator called flatten, which is going to convert your non-linear structure into linear. Then all positions are going to come. When you call this flatten of position, all your non-linear things will come into the linear fashion, so that based on that one we can group it. It's not possible. Yes. So by executing this one, I'll show you the same data set that we have now here. We have loaded the data set, and our data equals to, for each baseball, generate name comma, what are those things we have given? Name comma, team comma, flatten of position Getting the point what I'm doing here, friends? What is the impact of this statement? Are you able to understand? So your nonlinear structure is converted into linear, and that is referenced using the variable called position. And now if you say group G data equals to group R data by, what is that? R data by. So what we get here? Tell me what we get here.
So,
Position as your position as the group, and in that group we have all these people. Name,
Back, yes.
yes, the name of the player, to which team he belongs, and the position as a character array will be taken. So if you look closely at this one, now when I say generate, dump G data, now that is the reason why they didn't give that syntax directly like your map. Yes. So we only need to convert that non-linear into linear using your flatten operator. Flatten is a built-in operator. which is there with us. So under each position, who are all the players available you want to come to know, you will get that one. Look at this, you will get it. So overall what we get now here, from all entire data set, it will identify what are the different positions that are available. What are the different positions that are available, how it comes to know, because we said flatten of position. So it is going to convert this position, which is a non-linear, into linear fashion. So what we get, pitcher, designated hitter, and what are the different positions we have, batsman, and then we have what the positions we have here. Yeah, starting pitcher, third baseman, relief pitcher, and then we have a shortstop, designated hitter, a second baseman. All these are technically called as positions. So what is going to happen is your flatten operator is going to convert this non-linear into linear fashion, so that the group of positions what we get are referenced using your position. So inside this position, what we'll be having? We'll be having an array. Array of what? Array of positions. Now, we are grouping the data by position. So what I take is, from this array, the first one I take, for that position, who are all the players available, I get. Second position I take, for that who are all the players available, I get. The third one I take, who are all the players available for that one, I get. That is what the output you are going to see here. Now observe, for the designated hitter, all these are the players. You see here, for the designated hitter, you can see the same thing. Yes. For the relief pitcher, all these are the players. And for center fielder, I think you are noticing here, center fielder is the group name, and this entire thing is what we call it to be the inner bag. What this inner bag consists of? This inner bag consists of the list of the players whose role or position is center fielder. The same player may also hold one more position. If you look closely, here if you start seeing, in the setup picture, we have only this one. In the third baseman, you see these many people. Out of these, some may be part of the second baseman, some may be part of a designated hitter, that is different. But under each role or position, who are all the players available can be found out using this group by aspect. But it's not possible that you get the first element of your bag, because that is actually a non-linear one. That is the reason why we cannot access its value. Whereas map being a key value pair concept, we were able to comfortably get. How we were able to get? We were able to get comfortably with the help of profile hash. We give the key and its value is going to come. If the value is not present, we get empty. Hope you have understood everything, friends, what has been discussed here. Any questions on this, what we discussed? So with this, we have understood the Pig Latin language, how using this language you are able to write your statements, and as part of the statements, how you can make use of your operators, various operators, and make your relations. And we have understood clearly how the relations are being referenced using a bag. Inside the bag we have tuples, and inside the tuples we have fields, and fields comprise of data, and data is going to be, of course, we don't deal at the atom level. So atom is nothing but the character data of the data that is a part of your field. We don't have any data type for that one. We only has got a map, tuple and a bag. But if you dissect your bag, a bag is nothing but a set of tuples. A tuple has got ordered set of fields, and a field, each field represents one specific information about the entity, So all those informations put together, your entity, nothing but your tuple, and all such tuples. That is the reason why they made a comparison very clearly as part of the document. Bag is something like your table, and your tuple is something like your row, and field is something like your cell. I mean, where you have the data. When you write a table, something like this here, this part is what we call it to be field, and this entire thing is a row. This entire thing is what we call it to be table. This is what we call it to be cell. That cell is nothing but the field here. So they made the comparison even with your SQL to understand how data is being represented. So with this, you should be able to get fair understanding of how you load the data set and how you start working with the data set. So please go through this one, friends, and if you have any questions, please note it down. We can have a discussion on them probably in the next session. That makes sense?
Yeah.
So start working, friends. Please don't neglect. I've already shown you how you can access the documentation. I advise you to follow this documentation rather than studying any specific document or a book, because they are all biased. They are all the produce of this technical documentation given as part of until and unless these authors, the technical authors of the actual component development, until and unless they release something, no other can write any book or any document. So we are trying to look into the actual source from where we are getting the information about pig. So I advise you to go through this technical document directly. Tomorrow, if there is a new release in pig, we need not wait for someone to write a document on that. We can directly see here what delta, nothing but the difference from the previous release or version to this one. That only they are going to give it to you. You can just look at that small document. You can easily understand, oh, these are the changes from the last version to the current version. Fine. You can update easily by just going through the document for half an hour or so. That's the reason why I'm asking you to adopt this one from now onward, so that it will be easy for you to upgrade your skill set on the specific components and by large the Hadoop ecosystem. So go through this one, friends. You have any questions, let me know. We wind up at this level if you don't have any questions.
Srinivas, can you please send me this Fusion license? I'll send out the email to you.
Yeah, I'll do that one, Prasad. I'll do that one today. I'll send an email to you today.
Thank you.
Yeah. Right, friends. I'll catch up in the next discussion.